Welcome to the digital learning platform of Center for NEMS and Nanophotonics, Department of Electrical Engineering, IIT Madras. Electron beam evaporation. In this video, we will learn to deposit thin films using the electron beam evaporation, that is, E-beam technique. E-beam evaporation is a very important process of physical vapor deposition and can be used for applications like metallization and to prepare dielectric coatings, optical coatings, etc. Basically, a wide variety of materials can be deposited using E-beam evaporation. Equipment introduction and sample loading. Switch on the system and vent the chamber for sample loading. When the chamber pressure reads 1000 millibar atmospheric pressure, we can open the chamber to load the sample inside the chamber. About the chamber. Here we can see the chamber for vacuum deposition of metals or other materials. In the present case, we are going to deposit chromium. The chamber consists of two main sections, an electron source, which is here, and a crucible, hearth, section that holds the material we want to deposit. This is the crucible, where we keep the source material, which is evaporated using the focused electron beam on our target substrate, which is kept here. This crucible is made of tungsten. Crucibles are generally made of high melting point metals, or in some cases, ceramics are also used. Now, let us understand the electronic beam evaporation process. During this process, a current is first passed through a tungsten filament, which is our electron source. While the current is being passed, this source emits electrons. A high voltage is applied between the filament and the crucible hearth to accelerate these electrons towards the crucible. Two magnetic coils surround each pocket or crucible, and thus guided by their magnetic field, the electrons are focused towards the crucible, and when they arrive, the material kept in them is evaporated and it deposits onto the samples or substrate. Now we will show the sample loading. Our sample is a 2-inch silicon wafer, or we can use silicon wafer pieces. This is the sample holder. The samples are placed on the sample holder and are secured with metal pins or Kapton tape. Make sure it is tightly held. Now let us place the sample holder inside the chamber, and here it is held tightly by the bolt. We have to open the shutter in order to see the crucible. On the computer, click the process screen, then click on Shutter, which causes it to open. Here we have rotating pockets that hold the source material that can be dialed into position for different target materials to be applied to the substrate. Now close the shutter. Now close the chamber and start creating vacuum in the chamber. This starting vacuum is provided by the rotary pump till 10 to the power of minus 2 millibar. Then higher vacuum is provided by the turbo pump. And when the vacuum reaches 3.5 into 10 to the power of minus 6 millibar range, we fill the liquid nitrogen and wait for a few minutes till it reaches around 6.5 into 10 to the power of minus 7 millibar. Now set the metal and the deposition parameters in the process screen. Then click Start Process in the software. Deposition will start. From the chamber viewport, we can see the process inside the chamber. When the deposition will be completed, it will automatically stop the deposition. Now, switch off the sweep control, rotation drive, electron gun, and pressure gauge. Wait for the temperature to ramp down to room temperature. Unloading the sample and shut down. We will open the chamber as we have done in the beginning. And now we can see our samples after chrome deposition. At the end, let us close the chamber and create the roughing pressure at 10 to the power of minus 2 millibar inside. Switch off all switches in the reverse order as we did at the start of the process.